Hello, everybody. Welcome back to another Q&A with Dr. J. Today, we're going to take on a topic that is fraught with different opinions. It's also something that affects way too many people, and that is cancer and cancer genes. We don't worry so much about cancer genes, but what in fact is causing these cancer genes to turn on. Dr. J, I'm going to let you take it away.
Yeah, and that really is a much more important point. I have patients that come to me and they're like, "Oh, I got the BRCA gene, or I have the whatever the check gene, whatever that causes cancer." It was that there when you were born? Yeah, it was. Why is it only expressing now? That's
Hmm.
a much more important question. As we've talked about, genes load the gun, but the environment pulls the trigger. So what pulled the trigger? And there are several biochemical pathways that will start up the process of cancer and inhibit what are called the tumor suppressor genes that turn off cancer or just lead to apoptosis, where the cells die and just are excreted. And so one of the most important ones is in the mitochondrial area. The mitochondria are the energy producing organelles inside our cells. And so we take in food, it turns it into energy in the form of ATP. But if there's damage to the mitochondria, we actually produce a bunch of reactive oxygen species, and these are free radicals. And they're highly inflammatory, but also highly carcinogenic. And so we look at what has damaged your mitochondria, and often it's environmental damage. We look at chemicals and pesticides, heavy metals, electromagnetic fields, radiation, drugs, certain drugs and medications will do it. Fluoride and chlorine actually damage certain parts of the mitochondrial, the electron transport chain, which is deep down in the mitochondria. And so when that happens, that is acquired over time. And that's why we talk to patients about eat organic when you can, avoid medications, that are unnecessary, or antibiotics actually really damage mitochondria because they're of bacterial origin initially. Mitochondria are very susceptible to damage by the environment because they're not methylated. They can't put that protective methylation kind of coating over them. And so they are easily damaged. And a lot of these things weren't around generations ago. And so we haven't really developed a way to deal with a lot of these assaults on our mitochondria. And it's why we age, why we slow down, and our skin starts to wear down and our joints start to wear down. Our energy gets slower. We need a nap during the day. Our joints start to wear out. It's because our body is not producing as much ATP, or mitochondria is being damaged over time. I look at the little kids running around, all this energy, and I go, where'd that energy go? And actually, you can do a lot to repair the mitochondria, but the take home here with cancer is that if the mitochondria aren't producing energy, you get a backup of that biochemical pathway, and it increases glucose in the bloodstream. And glucose feeds cancers. Cancers are gobbling up all the extra sugar and being fed by it because you're not using it to make energy in the biochemical pathways there. So that's number one. But there's also other genetic variants that can set us up for cancers as well, like the superoxide dismutase and the catalase enzymes that are coded by our genes. They clean up all the peroxynitrites and superoxides that are carcinogenic, again, are highly inflammatory, or they're free radical formers. And in fact, I saw a patient yesterday who's got advanced prostate cancer, and that's exactly what was happening with him. Was he had mitochondrial damage somewhere along the way. I can't really pinpoint exactly what happened, although he did show for heavy metals, some mercury. I think he had a mouthful of mercury in his fillings, and then also had the genes that don't break down those free radicals that I was just talking about, the superoxide and peroxynitrite. But also on top of that, he was not methylating. And the methylation pathway is B12 folic acid, is two cogs essentially, pumps out methyl groups, and those methyl groups can turn off genes. So they're the off switch. What they do is basically cover it up so that the environment can't turn that gene on and cause it to express. So he had all of those things. He was a sitting duck for cancer. Plus, he had certain genetic variants, the SRD genes that are at high risk for prostate cancer. So it was like a multifactorial
A
thing.
perfect storm.
Yeah, it really was. And I think there's a lot we can do. That's the thing is we can get the mitochondria going. We can reduce those inflammatory molecules. We can help the body methylate correctly. We're not treating cancer. We're just getting the body healthy and we're plugging the holes of these genetic variants and getting them either turned off correctly or upregulated correctly so that they detox the mercury and the heavy metals, so that they get rid of the inflammatory molecules, and so that the mitochondria is now working correctly and we get the blood glucose down. And that has miraculous effects on the body. And again, I'm not saying anything about curing cancer. I'm not saying anything about curing any disease. The body does that when we just give it a little help and help it do what it's supposed to do naturally.
And what a gift that this patient has, because you told me before we got on that doctors have pretty much given up on him.
Yeah, yeah, they have.
So it also gives people back hope. And you've seen it work. So it's not hope with rainbows and unicorns. It's actually a good prognosis in the wings.
And it's biochemistry. It's really understanding your biochemistry. The other thing that damages mitochondria is chemotherapy.
Mm.
And people wonder, like, why did the cancer come back? Because you just disabled the mitochondria that could actually keep it gone. And so it's further damaging the problem, and recurrence is just very common.
Yeah. Yeah, it's a shame. Wishes, good wishes for that patient. There are more and more reports about the energy relationship to cancer cells. And we all probably have known somebody with cancer. It's exhausting. And so here we go with the relationship between the little powerhouses that produce our energy. And I read an article the other day by a cancer doctor, and she said that because cancer cells don't have their own source of energy, they steal it. Never mind anything else that's going on that you talked about genes. So it's super important to find out where, like you said, the holes are in the
Yeah,
biochemical pathways. And you're not going to know that without knowing your genetics, right?
yeah, exactly. And seeing where your risk factors are for it.
Mm.
Be proactive because that's our number two killer. Number one being cardiovascular disease, number two being cancer. It's just more and more common because our environment is more and more toxic.
Yeah, and young people listening to this, cancers are showing up in younger and younger people, especially stomach and colon cancer, which was surprising to me in
Right.
women in their 30s.
Yeah,
So something's happening.
very much. And there's a really good book called Tripping Over the Truth, and it was written, I think, in the 60s, maybe. Well, anyway, Otto Warburg was the first one to really discover that mitochondria was the source of cancers. Mitochondrial damage was way back in the 60s. And after that, the pharmaceutical companies started creating drugs, and his research was put aside. And now it's coming back to be shown that that is actually what is happening is the mitochondrial function is really a big piece of it. We talk about the enzymes throughout the body. The genes code for the enzymes. They all require ATP to function properly. So if you've got a genetic variant there and it's already reduced in its ability to function by about 70%, you take the ATP out and it's down to 80, 90% reduced. So we see a lot more genetic variants showing up as a problem because of the mitochondrial dysfunction, the lack of ATP.
I don't want anybody to misunderstand when we say just because you have a gene, you don't worry about it. It doesn't mean you're going to get it. A risk factor is still a risk factor.
Absolutely. Yeah.
Yeah, it's not going away because we think, oh, I'm a healthy person. So I think paying attention to the risk factors, the requirements of that risk factor. So a diminished ATP cycle might be different from a hormone cycle, but in either case, if you know what you're dealing with, you can then put into place the lifestyle pieces and the supplements if you need them. I just wanted to address that because I think sometimes people may misunderstand what we're saying.
I'm not saying the BRCA gene means nothing, but again, it was there when you were born and you didn't
Yeah,
have breast cancer when you were born. What turned it on? And
exactly. Exactly. I hope that cleared up something up for people listening. It is a scary topic. Nobody wants to hear you have cancer, and we're doing everything we can to make sure that fewer people get it, but then if people do get it, they can get the help they need to restore their body's natural healing ability.
Yeah, and that's really the key. Give the body what it needs and stand back. It's
Yeah.
okay.
All right, people will be back again with another Q&A. Dr. J, thank you.
Thank you, GC.